My name is Dr. Bradshaw, and this film is intended for the use of my 2612 RAD students, and this is page 8 of structural analysis. The first one on this page is called iliofemoral line. An iliofemoral line, for lack of a better description, is just a weird looking line. It is drawn along the lateral margins of the ilium, and so you just come down and trace it out, and then a joint space, femur head, neck of the femur to the greater trochanter. And then you go over to the other side and you look at along the ilium, across the joint, femur head, femur neck to the greater trochanter. And so you basically are looking at that side to side, and you're looking for there to be a symmetry between the two sides. If you don't see that, if you don't see symmetry, you would be wondering if you have, of course, a disassociation, such as things like a dislocation, slipped epiphysis, or a dislocated femur head, possibly even a fracture of the femur head or the femur neck. And so that would be what is indicated by an abnormal iliofemoral line. The next one on this page, which I'm going to switch out films and go back to that phantom view that I've been using, is called Skinner's. And Skinner's has two lines. Skinner's has two lines. The first line represents the mid-axis of the shaft of the femur. And so you just draw a line, and most people can just eye that without having to put dots. And so you just draw a line representing the mid-axis of the shaft of the femur. The second line is drawn perpendicular to the first one at the superiormost aspect of the greater trochanter. Perpendicular to the first line, which would be better if I used my protractor. It never seems to be laying where I'm standing when I'm trying to walk around this camera setup, so I apologize, but this would actually be more appropriate to do this correctly this way, to truly have a perpendicular line across the superiormost aspect of the greater trochanter. And this is, again, called Skinner's line. Now, normal is that the fovea capitis, which is about right here on this film, the fovea capitis should be above or level to this line. If you'll recall, this is a phantom view. This is not a real person. You notice the sacrum does not look normal. You see the foramen. You don't see any soft tissue. This is not a person. It's a plastic model. And so I don't really expect it to be normal. But the fovea capitis should be above or level to this line that's going across. If it is not, then you would worry, besides it's being a plastic model, you would worry about a fracture of the femoral neck or the shaft portion of the femur. And so that one is called Skinner's. And then the last one on this page is called Klein's. And Klein's just draws a line using our favorite word, tangent. And it is tangent to the superior surface of the femoral neck, tangent to the superior surface of the femoral neck, and you draw a line across like that, and then you're going to measure the distance from the line to the top edge of the femur head. And so I would just simply use my millimeter ruler and measure, and this one's measuring about 9 millimeters. Now, what you would do, of course, is that you would do Klein's line on the patient's other side, and we check to see if the number on this side matches the number on the other side. If you do have a match, then it's called bilateral symmetry, and that is considered normal. If you don't, then you need to be worried about something that would cause a disassociation of the femur, and that would be, again, fractures or dislocations, things of that nature. This concludes page 8. In fact, it includes all of the structural analysis, and I hope that you have a good evening.